All right, we're going to be identifying direct variation or constant proportionality. Our big thing is looking for what the constant values are. And so this is really just us working with more proportions, which you are experienced with. So given a piece of data, we know that the x is actually going to be what's listed on top in a graph, a piece of data more often, and the y is going to be the second one. But for our constant, you'll notice that y is over x. Now that's going to be very useful for you in much later math to recognize that y goes on top. But usually in the graph, it's x before y, and then when we do our constant, it's flipped. And it does make a big difference, and there is reasoning why they did that. So looking at our piece of information, we're going to take the 69 and the 2, and we're going to link those together. The 99 and the 3, and we're going to link those together, and the 129 and the 4. But you notice, once again, everything is flipped. Now, if I put these into simplest form, 2 69s won't reduce, 3 99s will reduce down to 133, and 4 29s won't reduce. They're not the same. And that's our key thing, is every piece of information has to be the same for it to be constant proportionality. Their proportions have to be constantly the same, an ongoing thing. And if you're still having trouble with reducing down to fractions, we do get to use calculators this go around, so turning them into decimals will show the same thing. They all have to have the same decimal value. So k is not the same for each ordered pair, so it is not constant proportionality, does not have direct variation. So same thing here. We'll notice we have decimals in this problem, so when we work this out, the x is the first piece of information, the y is the second, but we're going to flip that. And so I'm going to put 2.54 on top, 5.08 on top, and 12.7 on top. Now, when I change these all into decimals, I get 2.54. They're all the same. Constantly, our ordered pairs came up with the same thing, so our proportions are constantly the same. K in this case is 2.54. We do have direct variation. So we can put that back into our equation, y equals kx. Our k is at 2.54. So if we're ever asked to write it as an equation, once we find our k, we can do so. So try this problem on your own. If it does have constant proportionality, do go ahead and try to practice writing it in the equation. All right, we are going to resume. Remember that x is the first piece of information and y is the second, but we need to have it as y over x. So each of these reduces, none of these can reduce down. 2/5, 3/10, 4/15. None of them are the same, so I don't have a k, so I can't have direct variation. For our second one, 3/9, 4/12, and 5/15. I want you to do a comparison for this, same as last time. If you can get a k, I want you to write the equation y over x. Each one of these reduces down to to 3. And since they're all 3, our constant, our k, is actually going to be 3. So we can write our equation y equals k times x, y equals 3 times x. So we do have variation. Now, data can be represented as graphs as well.
When determining if a graph represents a direct variation or if a graph is proportional, both of those mean the same thing, you'll hear us refer to both of them, we have to determine two things. The first thing is it has to be a straight line, and the second thing is that it has to go through the origin. Both of those things have to happen in order for it to be proportional or a direct variation. If it's only a straight line but doesn't go through the origin, it is not a direct variation. Or if it goes through the origin but is not a straight line, it's not a direct variation. So once we've determined if it is a direct variation or if it is proportional, we have to determine what the constant of proportionality is. And in the last time you did the same thing with the tables, you put k equals y over x. We do the exact same thing here with the graph. We find good points, which means it goes right through the cross of each square in the graph, and the ones we found here is the point 2, -1. And remember, it has to be y over x. So the y for 2 over -1 is -1, and the x is 2. So when we write this as k equals y over x, we would get the constant of proportionality as being -1/2. So this one is proportional, and it has a constant of proportionality of -1/2 because that's what y over x is. So let's look at a second one. I want you guys to try this one. First determine, is it proportional? And if it is, what is the constant of proportionality? Okay, so let's look at this one. Remember, there were two things that we had to do to determine if it is a proportional graph. The first thing is it has to be a straight line. So you have to determine, is this a straight line? And we know that it is. The second thing that has to be met is it has to go through the origin. Does this line cross the origin? And your answer should be no. It does not cross the origin. So this is not a direct variation. It is not proportional, and we will not have a constant of proportionality because it's not a proportional graph. Here we have two problems we want you guys to try on your own and bring them into class ready to go. Thank you.